is a read-only segment. It is a shareable segment. Okay. And coming to the data segment, initialized data segment. So it contains explicitly initialized global and static variable. So global and static variable that are explicitly initialized, that are present in this segment. Initialized data segment contains the variables that are global and static and explicitly initialized in your program. The size of this segment is determined by the size of the values in the program source code and does not change at runtime. So during execution time, it will not change. The size of the segment will not change for this kind of variables. So this segment can be further classified into initialized read-only area, initialized read-write area. I told you already, few variables are initialized, and if you define it as a constant, the value in that variable will never change during the execution. Whereas few variables, if we specify with some value, but during execution, if you are updating the variable with a new value, such kind of variables are comes under read and write. Read and write. Here is an example. This is the program. We have two variables. So this is a global variable, and here this variable is declared as a static variable. So global and static variable, and here it is initialized. So it will be stored in data segment. Initialized static variable stored in data segment. Here also initialized global variable stored in data segment. Okay. And initialized read only data segment. So if you take this example, const int I, this is also initialized, this is also initialized, whereas this is constant. The value of I will never change during the execution of the program. So it is a read only data segment. So here the variable I will be stored in this data segment. So data segment split into two regions. One is initialized read only and another one is initialized read write. So in initialized read only segment, this variable I will be stored because it is a constant. The value of this variable will never change during the execution of the program. So this segment contains data elements that are initialized by the program and are read only. While the process is executing, the constant variable I is stored in this segment. So because I is a global variable. Okay. Then initialize read data segment. You take variable A. It is a global variable. The value we have assigned to A. During execution, the value may change. So it is a read write data segment. So the variable A will be stored in read write data segment. So here this segment contains data elements that are initialized by the program. So the variable A is stored in this segment. It is a global variable. So the value is changed during the process execution. Okay. Then BSS, block started by symbol, uninitialized data segment. So the variables that are not initialized to any value, that is called uninitialized variable, that will be stored in this data segment. So it contains all uninitialized global and static variable. BSS stands for block started by symbol. So here in this segment, all the global and static variable that are not initialized to any value in your program will be stored. So all the variables in this segment initialized by the 0 and a pointer with a null pointer. If you take this program, here we have two variables, uninitialized static variable stored in BSS, and here in data1. This is again uninitialized global variable stored in BSS. So here initialized data segment, this is BSS, block started by symbol. So here this is uninitialized variable or stored in that segment. And if you take this example, here the uninitialized variable is B, global variable B. So that will be stored in the BSS segment. So the BSS segment contains all global variables and static variables that are initialized to 0 or do not have explicit initialization in the source code. So as per this example, b is a global variable that will be stored in this BSS segment. And if you take another one, data, so this is an integer array. Again, this is uninitialized, so it will be stored in BSS segment. And coming to the stack, next one, stack. So stack usually used to store the local variables that are in the program. So if you take main, int x is a local variable, that is automatic variable, so that will be stored in stack segment. And also stack is used for storing the function parameters. So when you are invoking a user defined function from main, so when you are calling a function, so the argument to a function, what are the argument you are passing and what is the return address, that everything will be stored in stack area. So from the main, if you are invoking any function, that return address and what argument you are passing to a function, so all the things will be stored in stack along with the local variables or automatic variables of the functions also stored in stack. So the stack is used dynamically to store the automatic variables. So in this example, x is a automatic variable. So it's located at a higher address and grows and shrinks opposite to the heap segment. The stack contains local variables from function and related bookkeeping data. So stack is used to store the local variables. And second thing, stack frame will create in the stack when the function is called. So from the main, when you are invoking any user defined function, for example, if you are calling add function, so in that case a frame will be allocated. The stack frame will be created. So that contains the local variable, that is the argument to a function and the return value. So for each function, one stack frame will be used. Okay. See here, in this example, this is heap area and this is stack area. So here is the code. As this is a local variable, this variable will be stored in the stack region. So this is the stack region, and here you will be having the heap region. There is a gap between this because heap and stack both can grows and shrinks. So that is why here we have a gap in memory. Okay. Then coming to heap. So heap is used while a process running to allocate more data space dynamically to a process. That is, if any variable involves dynamic allocation, such kind of variables are stored in heap. If you take malloc, this one, so this ptr will be stored in heap. So ptr points to dynamically allocated memory from heap using malloc function. So this kind of variable which uses dynamic memory allocation, such kind of variables are stored in heap region. So it is used to allocate memory at runtime. Heap are managed by the memory management functions like malloc, cloc, free, etc. So mainly heap is used for these functions. malloc, cloc and free, that is memory management functions, utilizes heap area. So the heap area is shared by all the shared libraries and dynamically loaded modules in a process. It grows and shrinks in the opposite direction of the stack. So mainly heap is used at the runtime. So dynamic memory allocation schemes uses heap area. So if you take this program, this statement uses malloc function. So this variable will be stored in heap. This kind of variable utilizes space in heap. Are you clear up to this? If yes, type single is in the comment section. BSS. Okay, Kamesh. So this is for uninitialized data segment. So if you take the variables, this is a global variable. It is not initialized to any value. If you take this variable, it is a static variable. It is not initialized to any value. So these are nothing but the variable that is not assigned with any initial value. that is uninitialized variable. So such kind of global and static variables are stored in BSS. If you take this example, here int b, it is uninitialized. So this variable is a global variable, and if you take int data 10, it is an array, again it is uninitialized. So these two variables will be stored in BSS. So all the global and static variable that are initialized to 0 or do not have explicit initialization in the source code, so that will be stored in that region. Is it clear, Kamesh? Is it clear? Okay.
Yes, ma'am.
Then size in Unix. So this is one of the command. It is used for to find the sizes of different sections. So we have discussed text segment, data segment, BSS segment, right? So what will be the size of the segments of a process? So that we can find by using this command size in Unix. So size utility lists the section sizes and the total size for each object file or archive file. So here I am compiling one program 1.c namely. Then I am listing list -l dot slash a dot out. See here. So a dot out is an object file. What will be the permission? Everything will be displayed. After that, I'm using the size command. Size space object file name. If you give this one, so what will be the sections of a process? Three sections: text section, data section, BSS section. What is the size of each section? That is also displayed along with this is the total size of the object file. So if you add all these value, you will get 2175 in decimal. The same thing is represented in hexadecimal. So if you convert 2175 into hexadecimal, you'll be getting this value. So the file name is a.out. So for an object file, for the different sections, what is the size and what is the total size of that object file specified in both decimal and hexadecimal value. So by default, one line of output is generated for each object file. So here we have given dot slash a dot out. So for this object file, we are displaying the size sections of sections of uh, a dot out file. So each section size is displayed. So that is the usage of size command. See here, we'll see the difference. So here I have one program. I'm compiling it and I'm displaying the size. So here uninitialized variable is this one, only one variable. So BSS is 4. If you take this one, just I removed x equal to 10, I changed it to int x. See here the count is increased and here it is reduced. Here it is 548. Now that one become uninitialized, so here it is added. Here it is decremented by 4 and here it is incremented by 4. Okay. So size command will display the size of different sections of a process and also displays the total size of a process. If you are clear up to this, type SS in the comment section. Okay, so gap between heap and stack. I told you already, there is a gap always present between heap and stack. That because heap and stack, it will grows and shrinks because memory management. Because we are using dynamic memory management for heap, and here stack used for storing the functional parameter to store the functional parameter and the return address of a function. So one main program can invoke many user defined function. So here the stack area as well as the heap area can grow and shrink. So that is why here a gap is available between these two regions. Are you clear up to this? Type single S in the comment section. Okay. That I have to check Sheikh Yazar Ahmed. I will check and I will let you know. But usually if it is in functions also, it is an uninitialized. So for each process you will be having an image, right? Process image. So most probably it is also will be stored in BSS only, I think, but I will check and I will let you know. Next one, libraries in Unix. So there are two kinds of libraries. So here we are going to see about shared libraries. So the topic is shared library. Okay. Shared library. So first we'll see what is library. So you'll be having a pre-compiled pieces of code. So that can be reused in the program. So library is nothing but you'll be having a pre-compiled code. So that can be reused in our program. So if you take the mathematical functions, square root, all the things are available under math library. And then if you take scanf, printf, that comes under standard IO. So these are nothing but the predefined functions are available within a header file. So it is a pre-compiled code that can be reused in a program. So it is a reusable functions. It is a set of reusable functions. So in program, it is a common practice to reuse resources and libraries or essential part of it. So we can make use of the code which is already pre-compiled for our execution. So here is an example. You are invoking printf system call. So that is available in standard IO. So that invokes a system call called write. So for to print the message, this printf statement, it will be invoked in, it will be there in the standard C library. So this function invokes a write system call for to print the message greetings. Okay. So printf is nothing but it is a predefined function which is there in the standard library. We are invoking printf and scanf statement. So in turn, the printf statement invokes the API write system call for to print the message. So for each function, you will be having you have to invoke on the system side. We have to invoke some API. So if you take printf, it invokes the write system call. So there are two categories of library. One is static and another one is shared library. So here is the program. It is compiled here. So name of the program is 34.c. If you are using hyphen static, so if you are using this keyword while you are compiling, means that include the static library. That is the meaning. So if you are including the static library, then after that an object file is created. See here we are displaying the size of that object file. And if you exclude this statement hyphen static here, we have excluded, means that 34.c uses shared library. Okay, 34.c uses shared library. So here an object file is created. We are listing that object file. Size of that object file we are displaying. See the size difference of the segments. If you are using static, what will be the size? If you are not using the static, that is if you are using the shared library, what will be the size? So there is a difference. So if you are using the static library, this much size. If you are using the shared library, only this much is the size. So we'll see in detail. So library are classified into static and shared or dynamic library. So for each program, static libraries are individually added. So for each program, it is having a copy of static library. Whereas if you take dynamic, that is shared library, for the program, it uses the shared library, but the code will not be added to the program. The program X and Y utilizes the shared library without including the code of shared library in the program. Whereas here, the code, the pre-compiled code of static library are included in the program individually. So here program X is having its own copy of static library. Program Y is having the own copy of static library. That is why here the size is larger and here the size is smaller. So first we'll see how does a C program executes before moving into the static and shared library. So if you take your program first.c, we are compiling the program. So when you are compiling the program, an object file is created with the same name. So first.obj is nothing but after compilation, an object file is created with the same name of your file with the extension .obj. Then the linker. So a linker that will attaches the library functions. Okay, so that will add the library functions to this object file for to create an executable file. So the task of the linker is it will link the library routines to the object code to create an executable file with the same name with the extension .exe. That's it. So first .exe is the name of the executable file created by the linker by combining the object file and the library routines. After that, that executable file, this one, exe file, is loaded into memory for execution. So this is how normally a program executes. When you are executing your C program, first it is compiled, an object file is created with the same name of your file with obj extension. Then the task of the linker is it has to link all the library routines with the obj file. So after linking, an exe file is created, which is an executable file. It is loaded by the loader into the memory for execution. So linker generates the executable module of the source program. Loader loads the executable module to the main memory for execution. So this is the source file. So compiler compiles the file, an object file is created with the file name sample.obj. Original file is sample, so sample.obj. Then linker links the header files. It links the header files. It adds the header files to the object file so that an executable file is created with the name sample.exe. Then that executable file is loaded into memory for execution by the loader. Then you will be getting the output in the user screen. So this is an elaborated diagram of the previous one. Here also same thing. So in the source code, you will be having the header file. Source code along with you will be having .h files also. So the task of the preprocessor is it has to include the files. It has to replace the symbols. If you are using hash defined statement in your program, so all the symbols will be replaced with a value. So include the files that are needed by the program. So that is the task of pre-processing. Then compiler compiles the program. So object file is created with the extension .obj or .o. Then the static libraries are linked so that it creates an executable file .exe. Then loader loads the shared library, that is dynamic libraries are added in by the loader so that the program will be loaded into memory for execution. So we will be providing input and output will be generated by the CPU. So this is how the C program executes. So again the same thing. Name of the program is first.c. We will be compiling, an object file is created. .obj is not an executable file. So we will be creating an exe file which is executable file. So the task of the linker is it has to add the library functions. So usually library functions are not part of the C program. It is available in software. So the task of the linker is it has to add the library functions to the object code. So the definition of these functions are stored in their respective library. So if you take a math functions, it is available in math.h. So like that, All the definitions of the functions are stored in the respective library. So the task of the linker is it has to link the object file to the library function, and the program becomes an exe file for execution. Example, static libraries store files that are already pre-compiled. So it is a binary code. So this object files are incorporated into the compiled file of the source program. So assume that I have 1.c is the program name. It is compiled. An object file is created. 1.obj. Now the static library that will be added to 1.obj for to create exe file. Okay, we'll show the pictorial representation. So this is main.c. For that, the object file is created main.o. So this is the object file for main.o. Here it uses sort character. It is a function, library routine. So the library routine, this function, sort character object file is this one. So the linker combines the main.o object code, then sort character object code. So it is combined. So that will create a executable file. Now both object code, both binary codes are combined into a single file. It is an executable file. So this is the task of linker. Then loader that loads the exe file in RAM and informs the CPU with the starting point of the address where this program is loaded. So the task of the loader is it has to load the executable program into memory for execution, and it has to indicate what will be the starting address of the program where the program is loaded. The starting address have to be informed to the CPU for execution. So library are of two types: static library, shared library, or dynamic library. So here is a pictorial representation. If this program uses dynamic, what will be the size, and static linking, what will be the size. So first we'll see the static library. So it is also known as archive, static library. It consists of routines that are compiled and linked directly into the program. And every executable program have a copy of a library code. So here each program has its own copy of library code. So that is why the program size, executable program size increases. Whereas if you take shared library, it won't include the library code. So that is why it is less in size. The executable program size is lesser when compared to the executable program that uses static library. So for each program, it is library code. So the static library become part of your program. So lot of space is wasted. So and one more drawback is it cannot be upgraded easily because you have created an executable file. If you are updating the static library, then the executable file also need to be replaced. Okay, so first point, the drawback of static library is you are including the library code into your program, into your object file for to create an executable file. So lot of space is wasted. And suppose if you want to upgrade the static library, in that case, all the pre-compiled, that is executable files need to be replaced because we are adding a new library. We are upgrading the new library. So we have to change the previously executable files need to be replaced. Then coming to the shared library, it's also called dynamic library. So it is not included, the shared library are not included into the executable component but are tied to the execution. So here program X and program Y uses shared library, but this code is not included into the program, but it is tied to the program for execution purpose. So when you compile a program that uses a dynamic library, the library does not become part of your executable. It remains a separate unit. So on Windows, dynamic library extension is .dll, dynamic link library, and in Linux, the dynamic library extension is .a, sorry, .so, shared object, .so, shared object extension. So the advantage is it saves space because the dynamic library will be there in memory always. So when you are executing program, it is enough to load this object code program into memory for execution because this is already present in the memory. Okay. So advantage of dynamic library is many program can share one copy which saves space. So all the programs will share the same copy which is there in memory. So that saves space. Then the next advantage is that dynamic library can be upgraded to a newer version without replacing all of the executable that uses it. Suppose if I am updating shared library, so that won't affect the executable file of program X and program Y. Okay, so that is another biggest advantage of using the shared library. So if you are updating to a new version, no need to replace the executable file. Without replacing all of the executable file, we can upgrade the shared library. And here is an example. This is the program, namely memory layout.c. So we are creating an object file and we are displaying the size. So this is the size of each segment: text, data, BSS, then what is the decimal value, hexadecimal value, and the file name of this object file. Okay, so DEC specifies total image size in decimal and hex specifies in hexadecimal. That's it. So this is a normal thing. How the size command will display the sizes of different sections of a process. Now coming to static and shared library. If you are using static keyword for this file, so in that case, see the sizes. Here we are using the same program, but we are default to use the shared library. So see the segment size. So there's a great difference, large difference will be there. Okay, in the segments. And here is another example for this program. Here by using static keyword, here we are not using the static keyword. If you are excluding the static keyword means that the program uses the shared library. Here explicitly if you are specifying, then the program uses the static library. So here by using size command, after creating an object file by using size command, we are displaying the sizes of different sections of a process. See the size difference. So shared library, we can save the space, whereas here lot of space is wasted because each program have the own copy of the library code, whereas here it uses the shared copy. The program not included the shared library copy. It uses the copy, but it is not included in the program. It is not part of the executable file. Whereas here the library code is the part of the executable file. That is why we have larger size here. And here is the comparison. So first point, it happens as the last step of the compilation process after the program is placed in the memory. So in shared library are added during the loading process when executable file and libraries are added to the memory. So here in the compilation itself, in the linking step, we are adding the library, whereas here during runtime, and this is performed by the linker and this is performed by the OS. So when the library will be added, so here during linker time and this is during loading time, and this is much bigger in size because you will be adding the library code, right? So for the library code is part of each executable file, so that the program size is bigger, much bigger size executable file, whereas this one is smaller because we are using the shared copy. And one more point, we are not adding the library code into a program, so that is why size is smaller. And then time, it takes longer to execute. It's because we have to load everything. So loading into memory happens every time while executing, whereas here it is faster. Shared library is there in the memory already, so it is executed in a faster manner. And then external file changes. If you are changing any library file, then you have to recompile all the files. Okay. Whereas in case of shared library, no need to recompile the executable. Then coming to the compatibility, never has the compatibility issue since all code is in one executable module. Whereas here, if library removed from the system or a new compiler released, the dependent program will no longer work. Okay, so that is the drawback of dynamic library. Are you clear up to this?
Yes, ma'am.
Okay. Tomorrow second hour. Okay. Okay, I will send the notes to you up to date. Tomorrow also regular class. Take care. Bye.